Welcome back, everybody. Today we're going to talk about hypothesis testing on a proportion. All right, so if you remember a couple of videos ago, I talked about hypothesis testing. I said there were two population parameters where we do hypothesis testing. The first was mu, our population mean, which we got a lot of practice on. And our second is p, our population proportion. So today we're going to talk about our z-test on a population proportion. And let's just go through a couple of examples. So you could say something like, if you saw something in the problem like 59% of consumers purchase gifts on Father's Day. Or something like 35% of people go out to dinner once a week. All right. So whenever you see some sort of a percentage of the population, all right, that indicates that we're looking at a proportion. All right. So we got to remember a few things about our proportions. The first is, formulas to remember. And these were previously learned. The first is that mu equals n times p. All right. The second is that our standard deviation for the population is the square root of n times p times q. For our sample, it's the square root of pq over n. Our next is our z formula. I'm going to give that its own separate one. All right, it's z equals p hat minus p over our standard deviation, which is going to be pq divided by the square root of n, our sample standard deviation. Okay, now if you don't remember what some of these things mean, like, for example, p hat, sample proportion. All right, and that equals our x over n. All right, our p is population proportion. And our n is our sample size. All right, so if you're comfortable with these things, let's jump right into an example. All right, a telephone company representative estimates that 40% of its customers have call waiting. To test this hypothesis, she selected 100 customers and found 37 had call waiting. At alpha equals 0.01, is there enough evidence to reject the claim? All right, so we're going to use the traditional method. That's the method I'm more comfortable with. So our first step is we need to find our null hypothesis, which would be that p equals 40% or 0.40. Our alternative, since we're not given any sort of a direction, is that just our proportion is not equal to 0.40. Let's go to B. We want our critical value. All right, so when we're looking for our critical value, I need to use alpha equals 0.01. And note that it is a two-tailed test. And I'm going to go to my z-table just like I did when I was looking for my critical values for the mean. All right, so why don't you pause the video? Why don't you take a look and see if you can find the critical values? I'll give you the answer on the back end. All right, hopefully you found critical values. I found my critical values. That's a terrible equal sign. I'm going to make a better one. To equal plus or minus 2.58. All right. And let's see, for C, I need my test value now. Now for my test value, I'm going to use the formula that we had up here, right? This one for my test value. All right, so I'm going to say Z equals P hat minus P over the square root of PQ divided by N. And now my P hat, 37 over 100 or 0.37. So it's going to be 0.37 minus 0.40 over P, 0.40, 0.60 over N, which is 100. I'm going to ask you to pause the video now and do the calculation, and we'll talk about the answer on the back end. All right, hopefully you paused the video and got the same number I did. My number was negative 0.612. All right, now I've got to make a decision. Do I read, right? So my next step is make a decision. And to make a decision, I'm going to draw a very quick graph. Now, you may not need to draw this graph at this point, but then again, you might be watching this video for the first time and not watch some of the others. Now remember, if it falls in the shaded region, we are going to reject. If it does not fall in the shaded region, we are going to not reject. So my negative 0.612 falls outside of my rejection region. So I'm going to not reject the null hypothesis. And lastly, we need to summarize. I do like the summary. It does bring it back to the context of the problem. So if we summarize, we can say there is not enough evidence to reject the claim. All right, because over here, remember, we're always testing the null hypothesis, and this is the claim. I should have filled that in earlier. That's okay. All right, so let's take a look at the next example. An educator estimates that the dropout rate for seniors at high schools in Ohio is 15%. Last year, 38 seniors of a sample of 200 seniors withdrew. At alpha equals 0.05, is there enough evidence to reject the educator's claim? All right, so let's go through the steps again. My null hypothesis is that my proportion is 15% or 0.15. That's my claim. My alternative is that P is not equal to 0.15. All right, now for my critical value, I'm just going to use CV as my abbreviation for critical value. Now, here's the thing. Very similar to the last problem, except alpha is different. So alpha equals 0.05, and it's a two-tailed test. All right, so at this point, pause the video and find your critical values, and we'll talk about the answer on the back end. All right, so hopefully you paused the video and got the same critical value I did. I got plus or minus 1.96. And now let's move on to the test value. All right, I'm going to use the same formula I did before. So I'm just going to fill it in this time. My p hat is 0.19. All right, because what I did was I took my 38 who dropped out over my sample size of 200. And I got 0.19 minus my p, which we think is 0.15, divided by 0.15, 0.85 over 200. All right, why don't you guys again pause the video, do the calculation, and we'll see if our numbers match up. All right, see you in a minute. All right, so hopefully you paused the video. I got a value of, I'll make it better, 1.58. Now we need to make a decision, all right? So I'm going to scroll up to get a little bit more room. I'm going to say make decision. And again, I'm going to draw the picture. I definitely endorse drawing the picture while you're still making your way through hypothesis testing. Eventually, you are going to kind of figure out a way that you can do this without drawing the picture. But until then, I definitely endorse drawing it. 1.58 is going to come out like here. And that's outside of my rejection region. So I'm going to suggest that we do not reject. We do not reject our null hypothesis. And now let's make a summary. There is not enough evidence to reject the claim. again, that the dropout rate is, I will let you fill in the rest of that. All right, so now we've done a couple of two-tailed tests. Now I want to do just a couple more problems, but they're going to be one-tailed tests. All right, so let's get ready for the next example. A statistician read that at least 70% of the population oppose replacing the $1 bill with $1 coins. To see if the claim is valid, he selected a sample of 80 people and found that 55 were opposed to replacing the $1 bills. At alpha equals 0.01, test the claim that at least 70% of the population are opposed to the change. All right, so let's go through the steps one more time. All right, so my null hypothesis is that my proportion is either greater than or equal to 0.77, because it said in the problem, this is important, at least, which means the lowest it could be would be 77, but it could be more. All right, so once we saw that, we knew that that was our null hypothesis, and this is also our claim. And my alternative is that my proportion is less than 0.77. Now we're going to do our critical value one more time. Let's point out all of our elements. My alpha equals 0.01, and it is a left-tailed test. All right, so take that. Let's go to our z-chart and find our critical value. All right, hopefully you paused the video and found out that your critical value equals negative 2.33. Now so this is 1, that's 2. So the third step is my test value. And we're going to use the same formula that we've been using, the p hat minus p, right? But I'm just going to fill in the numbers here. All right, so my p hat, right, is out of 80 people, 55 were opposed. So my p hat is 0.6875. I'm going to keep as many of those decimal places as I can to try to get my z as good as I can get it. All right, so 0.6875 minus 0.77 over the square root of 0.77, 0.23 divided by 80. So again, pause the video. Let's do the calculation, see if our numbers match up. All right, so I got negative 1.75. All right, so now we got to figure out what our decision is, right? So we got to make a decision. All right, so if I'm going to make a decision again, I'm making a picture. And what I'm thinking is that it's got to fall in there for it to reject. But my negative 1.75 is before the rejection region, so we do not reject our null hypothesis. All right, and now we're going to summarize our results. right? So number 5 is our summary. There is not enough evidence to reject the claim that at least 70% of the people oppose replacing $1 bills with $1 coins. All right, I am going to tack on one more example. All right, and this example, we are going to use the p-value method. Now, you might remember the p-value method from a couple videos ago when we did our z-test for the mean. We can use it here as well. I do want to do at least one to practice. So let's get ready for the next example. All right, an attorney claims that more than 25% of all lawyers advertise. A sample of 200 lawyers in a city showed that 63 had used some form of advertising. At alpha equals 0.05, is there enough evidence to support the claim? And we are going to use the p-value method here just for a little extra practice. Realistically, you probably could use the traditional or the p-value method, but we're going to use the p-value method. So we're going to start the same way. Our null hypothesis is going to be that our proportion is less than or equal to 0.25. And then our claim is that our alternative is that our proportion is greater than 25%. All right, so now we're going to go right into our test value. And our test value is z equals, right? We'll use our p hat, right? Our p hat is going to be that 63 over 200. That was right in the problem, which is 0.315. And our p equals 0.25. And our q equals 0.75. So let's use that same formula we did before. Pause the video for just a minute. And why don't you try working out our test value? All right. Let's see what our test value is. All right. So when I worked it out, I got 2.12. And now we need to go to 2.12 on our chart. All right. And I see that, right? I'm just going to separate this to get a little organized, right? The area equals 0.9830. And because it is a right-tailed test, we need to do 1 minus that. So 1 minus 0.9830 equals 0.0170. All right. And for the p-value, if our p-value is less than our alpha, we reject the null. All right. And if we reject the null, we can summarize by saying there's enough evidence to support the claim. Right? Because if we look back, right, we see that the claim was our alternative. So if we reject the null, that means there's enough evidence to support the claim. So there's a quick review of our p-value method. It can be used here at this point. So just be aware that it is an option for you. All right, guys, thank you for listening, and I'll see you soon.